Alright guys, we're going to make a physics video here today, and it's going to be about understanding electrical circuits, and our example is going to be about capacitors. So right away, I have a circuit drawn out here, so I'd recommend stopping it right here, pausing it, and drawing this down. But before we get to how we're going to work this out, we have to look at some important things and a good way to memorize these things. So this is going to be kind of a funny example, but these are the best because they work. So let's say you're starting your physics class and you've got a really nerdy, hot student next to you, right? And you want to get to know them better. You want to see more of them. So what you're going to do is you're going to add them on their private Snapchat. So what does this mean? So let's capitalize P, V, S, and C. So you're going to add them on their private Snapchat, and that is because parallel capacitors have the same voltage. Okay, and this is huge. This is really important. So parallel capacitors have the same voltage, and along with that, series capacitors have the same charge. So you see what I did there? P corresponds to V and S corresponds to C, just like private Snapchat. So kind of just an easier thing to memorize. And we'll see what this looks like. But first, let's talk about our equation that we're going to use. So we have that Q charge equals C capacitance times V voltage. So this is going to be our central equation. And we can also rewrite it by rearranging it as V equals Q over C. So these are really important right here. We're going to use those. And also, step one to figuring out that circuit is going to be finding the equivalent capacitance. So there are two different types of equivalent capacitance. There's when capacitors are parallel to each other, which is CP. And to find that, you just simply add them up. So this is the equation that we're going to use. And also CS for when they're in series. That is written like this. And you'll probably be given these equations, but this is how I like to write them. So here are the key things that we have. This is really all that you need to solve these problems, and let's figure it out. So here's our main circuit right here. And to start solving this problem, let's look at a question. So if our question asks, find the voltage and the charge at each capacitor. Okay, so if this is our question, here is the symbol for a battery, and here is the symbol for a capacitor. So that's important. And so right here we have C2 and C3. So the way to recognize these is these are in parallel because they're on separate wires. Okay, so there's this main wire right here, and then it splits. It splits off in two directions, and they're parallel from each other. Now these capacitors right here, C4 and C5, are in series. They're on the same wire. So they're on just the single wire right here. So that's how you can tell. Okay, so if we're going to find the voltage and the charge at each of these capacitors, step one is to find the equivalent capacitance. Okay, so we're going to do that by using combinations of these equations right here. And let's do that. So if we're starting with this circuit, what we have to do is start to condense it. So we can see that C2 and C3 are parallel from each other. So we're going to combine those. So let's redraw our circuit with those two combined. Okay. So it's going to look something like this. This is still C1, but now that we've combined this middle one right here, we're going to call it C2, 3 to keep it clear. We've combined C2 and C3, so just to make things clear, we're going to call it C2, 3. Okay, and then we still have C4 and C5. So we have to calculate what this is. Because they're in parallel, we use the parallel equation, and we find that 6 microfarads plus 6 microfarads is 12 microfarads. Okay, so that's what C2, 3 is. Now we know everything at this level of our circuit. This one's still 12, this one's still 8, this one's still 4. And next, we can combine these two right here. So the steps to finding equivalent capacitance is just continuously redrawing our circuit and combining them at each step. Okay, we still have C1, which is 12. We still have C2, 3, which equals 12 also. And we've just combined C4 and C5. So those two are in series, so we have to use the series formula, which is this, right? So we took 1 over C4 plus 1 over C5, and then we're going to take the inverse of that. So let's calculate this out and see what our calculator says. So 1 over 8 plus 1 over 4, and then raise that to the power of -1. So we get 2.6 repeating microfarads. Okay, so that's what C4, 5 is. Okay, so now we know everything at that circuit, so we can continually combine it. And what we're going to combine next is C2, 3 with C4, 5. So we have our battery, we have C1, which is still the 12, and now we have this capacitor right here, which is C2, 3, 4, 5. Okay, and those are parallel from each other, so we're going to use the parallel equation and just add them up. So C2, 3 was 12 microfarads, plus C4, 5 was 2.6 repeating microfarads. So we get that is 14.6 repeating microfarads. Okay? Now we're really close to finding our total capacitance. We just have to combine these last ones. Sometimes students get confused by these two capacitors here because there's a bend here. But don't be confused, these two are still in series even though that there's that bend there. So let's redraw it. We finally have CEQ right here. And those two are in series, right? So we're going to take 1 over C2, 3, 4, 5, which is 14.6 repeating, plus 1 over 12, and take the inverse of it. So let's see what we get. 1 divided by 14.66666 plus 1 divided by 12, and then raise that to the -1. We get 6.6 microfarads. Okay, so finally we know CEQ. CEQ equals 6.6 microfarads. And back to where we started, we know the battery is 15 volts. So let's fill that in. 15 volts. Okay, and now this part is pretty easy. It's just adding capacitors together in series and parallel. But now to find the voltage at each of these capacitors and the charge at each of these, we have to work backwards. So step one was finding CEQ. So we go from this big circuit right here to just a small circuit. And then we have to start at that small circuit and work backwards. So let's see what I mean by that. So we have the equation Q charge equals C capacitance times V voltage. And at the circuit, we know the capacitance and we know the voltage, but we don't know Q. So C, we know that. V, we know that. But Q, we don't know that. So we have to figure that out. And we can do it using this equation. So what we're going to do with this circuit here is we're going to find the total charge. That's because we have the total voltage times the total capacitance. So we take 15 volts times 6.6 microfarads, and let's see what our calculator gives us. So 15 times 6.6 is 99 microcoulombs. So our charge is 99 microcoulombs. Okay, so now for this circuit right here, we have charge, we have voltage, and we have capacitance. So we have everything. Now we can work one step backwards to this circuit right here. So for this circuit, we know that we have capacitance, so we have that, and these two are important. These two capacitors right here are in series with each other. So earlier, what did we say about capacitors in series? So series capacitors have the same charge. Okay, so what does that actually mean? They have the same charge with each other, but they also have the same charge as what we calculated back here. So let's write out what this actually means. Q total equals Q1, which equals Q2, 3, 4, 5. So this is what I mean by capacitors in series have the same charge. Okay, and we don't know the voltage. So now this is the thing that we don't know and that we have to figure out. So we can rearrange our equation Q equals C times V to figure out what V is. So V equals Q divided by C. So let's say we're looking at capacitor 1 and we're trying to find the voltage there. So V1 equals Q1 over C1. So Q1 is equal to Q total, which we found to be 99 microcoulombs, over C1, the capacitance, which is 12 microfarads. So 99 divided by 12 equals 8.25 volts. Okay, so let's highlight some things real quick. We have V1, which is the 8.25 volts. We have Q1, which is 99 microfarads. So that's it. We just have those two right now. Okay, and let's keep working. So also with this equation here, we can calculate V2, 3, 4, 5. And although that doesn't really find us the voltage at a specific capacitor yet, we're going to continue working backwards to find that out. So V2, 3, 4, 5 equals Q 2, 3, 4, 5. divided by C 2, 3, 4, 5. Okay, so we still have 99 microcoulombs divided by the capacitance at that capacitor. So that was the 14.6 microfarads. 14.6 repeating microfarads. And let's see what we get. So 99 divided by 14.6 repeating is 6.75 volts. Okay? So now at this circuit right here, we have everything. We've calculated the voltage, we knew the charge from our rule, and capacitance was given to us when we figured it out. Okay, so now that we know everything, we can again go one step backwards. Now, you have to ask yourself, what's the difference between this circuit here and this circuit here? So we can see that the difference is that the capacitor C2345 was split into C23, which is parallel to C4, 5. So now that those two are parallel, we know that they have the same voltage from our rule. So parallel, same voltage. So V2, 3 equals V4, 5, which equals V2, 3, 4, 5, which we just calculated. So we know that these voltages are going to be the 6.75 volts. Okay, so voltage we know, capacitance we know, but charge we don't know. So we have to figure out charge. This is just a repetitive process of using the same equation every step of the way. So Q2, 3 equals C2, 3 times V2, 3. So let's see what that is. We have 12 microfarads times the 6.75 volts, and that is 81 microcoulombs. Okay, and doing the same thing for the other capacitor. Let's see, we have 2.6 repeating microfarads times its voltage, which will equal 18 microcoulombs. Okay, so these are the things we figured out. And again, we're going to work one step backwards. So we had the charge, we had the capacitance, and the voltage. So again, ask yourself, what's different between this circuit and this circuit? And we can see that the difference is that C4, 5 was now split into C4 in series with C5. Okay, and using our rule, capacitors in series have the same charge. So C4 equals, same charge, Q4 equals Q5, which equals Q4, 5. Okay, and we just calculated that to be 18 microcoulombs. Okay, so we know the charge, we know the capacitance that was given, but we don't know the voltage. So the one we don't know is the one we have to figure out. So again, rearranging this equation, V equals Q divided by C. So if we're looking for V4, it'll equal Q4 divided by C4. And Q4 is going to be the 18 microcoulombs divided by the capacitance, 8 microfarads. Okay, so let's see what we get. 18 divided by 8, 2.25 volts. Okay, so now this is something that we need. And let's do the same thing with the fifth capacitor. Q5 divided by, let's see here, C5. Okay, and this will be 18 microcoulombs divided by 4 microfarads. So that should just be double, 4.5 volts. Okay. So now this is helping us answer our question. And finally, we can go back to our initial circuit. So the difference between this circuit here, our first circuit, and this circuit here is in C2, 3. So we can see that C2, 3 is now split into 2 parallel capacitors, C2 in parallel with C3. So because those two are in parallel, they're going to have the same voltage. So V2 equals V3, which equals V2, 3. Okay? So let's see here. Okay, we have, hold on. Okay, do we know the voltage at C2, 3? Okay, we do from back here. So we know the voltage from all the way back here. Okay, and it's going to be the 6.75 volts. 6.75 volts. All right, so now that we know that those are in parallel and we have the voltage, we can figure out what we don't know. No voltage, we have their capacitance, but we don't know their charge. So Q equals C times V. So if we calculate Q2, we take C2, which is 6 microfarads, times V2, which is the 6.75 volts. And what do we get for that? So 6 times 6.75 equals 40.5 microcoulombs. Okay, so that answers our question. That's the charge at the second capacitor. And let's do the same thing for Q3. So C3 is 6 microfarads again, times 6.75 volts. So again, it's going to be that 40.5 microcoulombs. Okay. So that's good. So let's think about this. We have Q2 and Q3, but we also have V2, right? And we have V3. Highlight these. Okay. And we have V4 and V5, and we also have Q4 and Q5, right? Okay. And we have V1 and Q1, and that's it. That's all that we had to calculate. So our question was, Find the voltage and the charge at each capacitor. So the circuit contains 5 different capacitors. We have the voltage and charge at 2 and 3, 4 and 5, and 1. Alright, so that's how you work backwards to find the voltage and charge at each capacitor. Thank you guys for watching. I'll be making more. I'll be making another video about this with resistors and a bunch of other stuff. So thank you.